Hello everyone, and welcome to another video in my channel. In this video, I have a problem in trig identities to solve. I am given if cos raised to power 4 theta is equal to a cos 4 theta plus b cos 2 theta plus c, where a, b, and c are constants and they are members of the set of rational numbers. I am required to find the value of a, b, c. I encountered a problem when I was solving this problem. I will show you what that problem is and how I resolved it. It's just a simple substitution that will solve the problem. However, before I proceed, I would like you to do me a favor. Please like this video, subscribe to my channel if you haven't done so, and share this video to your loved ones. I would also like to read your comments in the comment section, particularly how you were able to solve this problem using another method. I would like you to share your method in the comment section. Now, to solve the problem, I will first of all take cos raised to power 4 theta and rewrite it as cos square theta all raised to power 2. Now, I will now look for a way to write an equivalent of this. So if I have cos 2 theta, I can expand it using cos square theta minus sine square theta. This is the trig identity of this. So I'll expand this using these trig identities. However, sine square theta is equal to 1 minus cos square theta. Now we are going to put this in place of sine square theta here. So cos 2 theta is equal to cos square theta minus 1 minus cos square theta. Opening this bracket, we have cos square theta minus 1 plus cos square theta. That is our cos 2 theta. Therefore, if we add this together, we have 2 cos square theta minus 1 is equal to cos 2 theta. Now let's take every other thing to the other side and make cos square theta the subject. So cos square theta is equal to cos 2 theta plus 1 all over 2, or 1 over 2 bracket cos 2 theta plus 1, close the bracket. Now I'm going to put this in place of cos square theta here. So cos 4 as power theta is equal to 1 over 2 cos 2 theta plus 1 all squared. Let's remember there is a bracket here. Good. So if I expand it, I have 1 over 2 cos 2 theta plus 1 over 2 all raised to power 2. Now I can expand this one as 1 over 4 cos square 2 theta plus multiplying this by itself to get this. Now this multiply by this, I'll get 1 over 4 times 2 cos 2 theta. So if I multiply this by this, I'll get half of it. Then multiply this by this, I'll get the other half. It becomes 1 over 4 times 2 times cos 2 theta. Now 1 over 2 times 1 over 2 will give us 1 over 4. So cos 4 theta will now be equal to 1 over 4 cos square 2 theta plus, if I divide this by this, I'll get 1 over 2, then cos 2 theta plus 1 over 4. Now I was saying I encountered a problem at the beginning of this video. That problem is this part. But how did I solve that problem? I can let 2 theta equals to phi. So cos squared 2 theta is now cos squared phi. Now whatever we did to this part, we can also do it to this part. That means that cos squared phi will now be equal to, we are going to take this, that becomes 1 over 2 bracket cos 2 phi plus 1. Very good. Now remembering that 2 theta is phi, it becomes 1 over 2 cos 4 theta plus 1. So I'm going to replace this where I have this in the equation, it becomes cos raised to the power 4 theta equals to 1 over 4 times 1 over 2 brackets cos 4 theta plus 1, close the bracket. Now other part becomes plus 1 over 2 cos 2 theta plus 1 over 4. Now if I open this bracket, it becomes cos 4 theta equals to 1 over 4 times 1 over 2 is 1 over 8. Then 1 over 8 times this will give us cos 4 theta plus, and here becomes 1 over 8 again. Then plus, the other part is 1 over 2 cos 2 theta plus 1 over 4. Great. So let me add these two together. It becomes 1 over 8 cos 4 theta plus 1 over 2 cos 2 theta plus when we add these two together, we get 3 over 8. So this is cos 4 theta. Now let's recall that the question says A, B, and C are constant. So our A is 1 over 8, then our B is 1 over 2, and our C is 3 over 8. Therefore, A, B, C is equal to 1 over 8, 1 over 2, 3 over 8. This becomes the answer.